Ever wondered what makes the difference between an app that's a joy to use and one that's just clunky? Well, it's not just about writing code. See, the best software is actually designed, and it's often designed using these powerful, reusable solutions called design patterns. You can think of them like secret blueprints that architects use to build software that's built to last.
Because that's the real challenge, right? I mean, as you keep adding features and the complexity just piles up, how do you stop your app from becoming this fragile, unmanageable beast? How do you build something that's actually robust, flexible, and, easy to maintain down the line?
So, to really get our heads around this, we're going to do a little case study. We're going to build a simple drawing application from scratch. And as we start adding new features, we'll see exactly what kind of problems pop up and which design patterns can come to the rescue.
Every single time a new feature gets requested, the software architect is facing a really critical choice. It's this constant balancing act. On one hand, you've got these awesome new features that your users are asking for. But on the other, you have the integrity of your design. And if you tip those scales too far one way, well, the whole thing can just come crashing down.
When we first start our drawing app, everything's easy. We've got some data for our shapes, a little bit of logic to draw them on the screen, and some code to handle mouse clicks. But pretty soon, all that stuff gets tangled together. And this tangled mess, well, developers have a name for it. It's a low cohesion system, which basically means nothing has a single clear job. Your click-handling code is mixed in with your drawing code and your data-saving code. It's a total recipe for bugs and headaches.
So our first job is to untangle this mess. And to do that, we're going to turn to a classic architectural pattern, Model View Controller, or MVC for short.
The whole idea behind MVC is something called separation of concerns. It's like taking that tangled ball of yarn we just talked about and neatly separating it into 3 distinct spools. You've got the model for your data, the view for your display, and the controller for all the user input. Each part has one job, and one job only.
Okay, this table breaks it down perfectly. Think about it like this. The model is the brain of the whole operation. It holds all the important data, our shapes, our lines, our circles, but has absolutely no idea what they look like. Then you have the view. That's the face. Its only job's to look at the model and draw what it sees on the screen. And finally, the controller. That's the hands. It listens for user input, mouse clicks and things, and then it tells the model or the view what to do. This creates a really clean, decoupled system.
All right, let's move on to our next feature and see how this all builds. Our app is working, our code is finally organized, and now, of course, our users want to draw more complex stuff. They want to be able to group shapes together.
Now here's the tricky part. How are we supposed to write code that can treat a single, simple line and a complex group of, say, 100 shapes in the exact same way? We definitely don't want to write separate logic for move a line and move a group. We need a uniform way to handle both of them.
The solution is this really elegant composite pattern. What it does is organize our shapes into a tree structure. Individual shapes, like a line or a circle, are the leaves of the tree. And groups of shapes are the branches, which can hold either leaves or even other branches. The real magic here is that both the leaf and the branch can understand the exact same commands, like draw or move.
And this is where it all comes together. Our code doesn't even need to know if it's talking to a single object or a super complex group. It just sends a command, like move yourself, to the top of the tree, and that command just automatically flows down to every single part. It's incredibly powerful.
Okay, new challenge. Our drawing app is a hit, but now management wants it to run on different operating systems, and each of those has its own unique way of drawing things on the screen, its own UI toolkit.
So, our first instinct might be to use a basic programming concept called inheritance. We could create specialized versions of our shapes for each system. So we'd have our line class and then a Windows line, a Mac line, and an Android line. But now, imagine doing that for circles, labels, and polygons. You see the problem, right? This diagram shows what the source material calls an unacceptable explosion in the number of classes. It is a total maintenance nightmare.
And this is where the bridge pattern is just so clever. It completely avoids this explosion by creating 2 separate hierarchies. On one side, you have your shapes, the what. On the other side, you have the different UI toolkits, the how. And that bridge in the middle connects them, letting us combine any shape with any UI toolkit without having to create a new class every single time.
All right, for our final feature, we're going to tackle something every single user wants in an editor: the ability to hit Ctrl-Z and just undo a mistake.
Now this sounds pretty simple, but it's actually really complex when you get into it. We need to be able to undo multiple steps and then be able to redo them if we want. We can't just save a copy of the entire drawing after every single click. That would be insanely inefficient. We need a much smarter way.
This quote really gets to the core of the command pattern. The big idea is this. Instead of just doing an action, like drawing a line, we first wrap that entire request into its very own object, a command object. And this little object holds everything we need to both do the action and undo it.
What's so cool about this slide is how it visualizes the whole process. So every time a user adds a line, a new command object gets created. And as you can see in the diagram, it's pushed onto the history stack. Now when you hit undo, we just pop the last command off that stack and tell it to reverse itself. And if you want to redo, well, that undone command gets moved over to the redo stack, all ready to be executed again. It's basically a perfect system for time travel in your code.
So the crucial takeaway is this simple but incredibly powerful flow. The action becomes its own self-contained unit that knows exactly how to execute itself and how to reverse itself. This makes building a really complex, multi-level undo/redo system surprisingly straightforward.
And there you have it. Just by solving a few problems in our simple drawing app, we've added 4 incredibly powerful patterns to our Software Architects Toolkit. Each one is a proven blueprint for solving a common, recurring design challenge that you're going to see over and over again. And this is the really cool part. Once you know what these patterns are, you start seeing them everywhere, in your operating system, in your web browser, and pretty much every app you use every day. They are the invisible architecture of our digital world. So, the next time you're using an app, take a closer look. What kind of blueprints can you find?